Hello there, my name is Ajiboye Isaac, and today we want to learn an important topic in further mathematics. That topic is partial fraction. Say it with me, partial fraction. Right? Our learning objectives. At the end of the lesson, learners should be able to simplify partial fraction into single complex fraction. Resolve complex fraction with linear factor denominator into its partial fraction. Resolve complex fraction with repeated linear factor denominator into its partial fraction. Key vocabulary words. Linear factor. A linear factor is a factor with degree 1 as highest degree on its variable or variables. For example, 2y plus 3x is a linear factor simply because the highest power on the variable or variables is 1. Alright? So the power on y is 1 and the power on x is 1. And that makes 2y plus 3x a linear factor. We know we could have quadratic factor. In that case, the power on the variable, either x or y, will be 2. Algebraic fractions. Algebraic fraction is a fraction with variables and constants. Example, 2x plus 3 over x minus 1 all raised to the power of 2. You would notice that it's a fraction. We have a numerator and a denominator. And because of the variable x that is in the numerator and denominator, that makes it an algebraic fraction. Coefficient. A coefficient of a variable is a number attached to that variable, right? For instance, in the previous example of algebraic fraction, the coefficient of x in the numerator is 2 because 2 is attached to variable x. So therefore, the coefficient of x in the numerator is 2. A constant. A constant in an expression is a term in that expression whose value does not change. A constant in an expression is a term in the expression whose value does not change. For instance, in the above example of algebraic fraction, 3 is a constant, minus 1 is a constant. Those values do not change because they do not have any variable attached to them. A variable is a term in an expression whose value is liable to change. That can they can vary in its value. That is what we mean by a variable. Partial fraction. Partial fractions are simple algebraic fractions that combine to form a single complex fraction. I'll take that again. A partial fraction partial fractions are simple algebraic fractions that combine to form single complex fraction. However, we can resolve the complex fraction into its partial fraction. So it is our main objective to first know how to combine simple partial fractions into a complex fraction and also to resolve a complex fraction back to its simple partial fraction. Example, simplify 3 over x plus 7 over x minus 2. The first thing to do will be to find the LCM of the denominators, which in this case will be x into bracket x minus 2. And then we use the denominators of the simple partial fractions, to divide the LCM of the denominators. So by so doing, when we do x open bracket x minus 2 divided by x, we get x minus 2. And therefore, we'll multiply by in the numerator 3. So that will give us 3 open bracket x minus 2 close bracket plus, if you do the same thing for the denominator of the second simple partial fraction, we'll see that we'll get 7x. So that if we open the bracket, we have 3x minus 6 plus 7x over x open bracket x minus 2. So if we collect like terms and simplify, we have 3x minus 6 over x squared minus 2x. This therefore suggests that our simple partial fractions have been combined. The simple partial fraction 3 over x plus 7 and 7 over x minus 2 have been combined to form a complex fraction of 3x minus 6 over x squared minus 2x. Therefore, the partial fraction of 3x minus 6 over x squared minus 2x are 3 over x and 7 over x minus 2. So, we can, however, resolve the complex fraction back into its partial fractions. The determinant to achieve this is the denominator of the complex fraction, right? We have different methods and we have different complex fractions. We could have a complex fraction with distinct linear factors. We could have a complex fraction of denominator distinct linear factors. So if you have a complex fraction and we observe that the denominator are simple linear factors, then how do we handle it? How do we resolve it? So we simply take a constant as a numerator over the linear factor, as many as possible that it may be. So for instance, if we have a complex fraction f of x over a1x plus b into bracket a2x plus c into bracket a3x plus d. Therefore means that our simple partial fraction of such complex fraction will be equals to a over a1x plus b over a2x plus c over a3x plus d. Mind you, you would notice that the highest power of the factors in the denominator is 1. That is, the x there in those brackets have the highest power of 1. So that is why we refer to them as linear factor. For example, resolve 3x minus 5 over x squared plus x minus 6 into its partial fraction. Resolve 3x minus 5 over x squared plus x minus 6 into its partial fraction. Solution. We first factorize the denominator into linear denominator. It's a quadratic expression, and so we can factorize a quadratic expression. In the situation where you can factorize, you go ahead and factorize, but there may be situations where you cannot factorize. That is another type of denominator. But for now, let's see if we can factorize x squared plus x minus 6. If we factorize, we will get open bracket x minus 2 close bracket, open bracket x plus 3 close bracket, on factorization of the quadratic denominator. Therefore, our complex fraction will therefore be equal to a over x minus 2, the first linear factor, plus b over x plus 3, the second linear factor of the denominator of the complex fraction. So the next thing to do is to multiply through by the LCM. We multiply through by the LCM. If we multiply through by the LCM, you will notice that the denominator and the LCM will cancel out. That is on the left hand side of the equation, and the factors we divide out alternatively, okay, on the right hand side. So therefore, we would have 3x minus 5 is equal to a open bracket, x plus 3, close bracket, plus b, open bracket, x minus 2, then you close bracket. If you open the bracket, we have our 3x minus 5 to be equals to ax plus 3a plus 3b plus bx rather minus 2b. Then we collect like terms. We have 3x minus 5 equals to ax plus bx plus 3a minus 2b. Therefore, if we now factorize, we pair and we group in pairs and then factorize. Our 3x minus 5 will now be equals to x, open bracket, a plus b plus 3a minus 2b. Then the next thing to do is to compare coefficients, because if the two expressions are equal, then it means that the coefficients of the variables, of the corresponding variables, will be equal. That is, if the two expressions are equal, then a plus b must be equals to 3, because those two are the coefficients of the two expressions on the left and on the right. I say that again. A plus b is equal to 3 simply because the coefficient of the coefficient of x in the expression on the left hand side is 3, and the coefficient of x on the right hand side of the expression is a plus b. So we equate the two coefficients. So therefore, we have a plus b equals to 3. On the other hand, if you look at the left hand side, the constant there is minus 5. And on the right hand side, the constants are 3a minus 2b. Therefore, for the two expressions to be equal, for the equality to be satisfied, the minus 5 must be equal to 3a minus 2b, or 3a minus 2b is equal to minus 5. This seems to be simultaneous equation, and we can solve by simultaneous method. Okay, so let's make b, or let's make a subject so that we can substitute in the second equation. So we have 3 open bracket 3 minus b close bracket minus 2b equals to minus 5. That's by substituting for a. That is, we made a subject in the first equation. That will give you a equals to 3 minus b, and then substitute in the second equation, so that when you open the bracket, you have 9 minus 3b minus 2b equals to minus 5. If you simplify, minus 5b will be equals to minus 5 minus 9, and that will give us b to be equals to 14 over 5. Now that we know that our b is equal to 14 over 5, and already we have stated that a is equal to 3 minus b, therefore a will therefore be equals to 3 minus 14 over 5, which will give us 15 minus 14 over 5. Our a therefore is equal to 1 over 5. So our complex fraction, which is 3x minus 5 over x squared plus x minus 6, will be equal to 1 over 5 open bracket x minus 2 plus 14 over 5x plus 3 open bracket and close. You can see that we started with a complex fraction, and in the end we got simple partial fractions. If you can check and confirm that if you combine the two simple fraction, that is 1 over 5 open bracket x minus 2 close bracket plus 14 over 5 open bracket x plus 3 close bracket, you will see that you will get the complex fraction on the left hand side. You can confirm. I would even employ you to confirm. We can have repeated factors as a denominator of a complex fraction. Repeated factors as the denominators of a complex fraction. So how do we handle such situation? It's very simple. We take one factor at a time and place a constant as numerator. So for example, if you have f of x over ax plus b raised to the power of 3, it will therefore be equals to a over ax plus b over ax plus b all squared plus c over ax plus b all cube. This will be the simple partial fraction of such complex fraction. For example, resolve x plus 9 over 2x plus 5 raised to the power of 2 into its partial fraction. Solution: x plus 9 over 2x plus 5 all bracket square will therefore be equals to a over 2x plus 5 plus b over 2x plus 5 all square. Multiply by the LCM. If we multiply by the LCM, we'll see we have x plus 9 equals to a open bracket 2x plus 5 close bracket plus b, and x plus 9 will now be equals to 2ax plus 5a plus b. If we compare coefficients on the left hand side, the coefficient of x is 1. On the right hand side, the coefficient of x is 2a. Therefore, making a subject to become a will become 1 over 2. Also, the constant on the left hand side is 9, and the constant on the left hand side is 9, and the constant on the right hand side is 5a plus b. So if we equate that, we'll see that we say 5a plus b is equal to 9. And already we have a as 1 over 2. So 5 open bracket 1 over 2 plus b will be equals to 9. And therefore, b will be equals to 9 minus 5 over 2, which will be equals to 13 over 2. So, on substituting the value of a and b into the expression we got, we have x plus 9 over 2x plus 5 raised to the power of 2 is equal to 1 over 2 open bracket 2x plus 5 close bracket plus 13 over 2 open bracket 2x plus 5 close bracket square. So you can as well confirm that the two simple partial fractions we got can be combined to give the complex fraction. Please attempt the classwork just to show that you understood what I have explained. And don't forget the steps. The steps is I've given you the general expression for linear factors and repeated linear factors. So once you can do that, the next step will be that you multiply through by the LCM and compare coefficients. That's all. So once you compare the coefficients, you'll be able to get the constants, and that will be the case. So attempt the classwork and forward your attempt to my WhatsApp number. Then this is assignment. Please attempt the assignment as well, and it follows suit. Just apply the same method. Okay, in the first question, you have been given the expression, the complex fraction has been given in form of simple partial fraction. So all you need to do now is follow the same steps and see how to get p. That is, you compare coefficient, you multiply through by the LCM, and then you compare coefficients and get your constants. And do the second one too. Please forward your attempt of the assignment and the classwork to my WhatsApp number. The assignment is due first thing tomorrow morning. So I'll be expecting your comment, I'll be expecting your question, and I'll be expecting your attempts. Thank you.